Hello friends, this is part 3 of Astronomy and Astrophysics paper, DSE paper 2 and 2022, Dibrugarh University. So we have already solved question number 1 and 2, right? So now we're going to start solving question number 3, and this is my Insta ID, Oza Lekhajit 123. If you want to follow me, then you can follow me on Insta. So now let's start. So here is the question number 3a. Discuss how masses are determined in binary star system. So let me answer this question. Suppose let us consider a binary star system. This is question number 3a. Answer to question number 3a. Suppose one star is here, its mass is capital M1, and another star is here. This is mass of this star is suppose capital M2, and distance between these two is suppose small a. Let me consider that small a, and this is the suppose center of mass of this system. This is the center of mass, and distance from the center of mass to this star is suppose small a1, and to that star is suppose small a2. Let me consider that way. Okay, so let us suppose, let me write the answer. Let us suppose or let us consider capital M1 and capital M2 are the masses of the two stars of a binary star system, right? And also let us consider small a is equal to distance between the two stars. Distance between the two stars a1 is the, suppose let me take a1 is the distance of the center of mass from the star of mass m1. Okay, so distance from the center of mass of the star of mass m1, and a2 is the distance from the center of mass of the star of mass m2 So let me use here capital M and capital M1, and here is capital M2, right? Now P is the period of revolution, period of the binary system. Now you see, and we know that capital G is the universal gravitational constant. So now let me take a new slide. By Kepler's law, let me take the third law, Kepler's third law of planetary motion, that this square of the period is proportional to the cube of the this distance between these two stars. Okay, so this this is proportional, not equal here. So which means we can say that p square by a cube is equal to constant. Okay, is equal to constant, and that constant is equal to 4 pi square capital G capital M1 plus capital M2, right? So this is the constant here. Now you see, now if we simplify this, then what we're gonna have capital G M1 plus M2, sorry, here capital M2 by 4 pi square is equal to a cube by p square. And now if you use this value instead of SI unit, if you use the values of period, this distance here, then in such units, let me use the period in years instead of SI unit, and this distance in astronomical unit. Then you see, if P is in astronomical unit AU and A is in years, sorry, here it should be A, sorry, in astronomical unit, here is the distance, and P is the period, so it should be in years. Then this above equation becomes M1 plus M2 is equal to a cube by p cube. Okay, and this where the sum of the mass is M1 plus M2 in solar mass, not in kilogram, it is in solar mass. Okay, now again you see, let me use this one again. You see, now you see, if this mass is greater than this one, then the center of mass will shift towards this. That means greater this mass and lesser this distance, so inversely proportional. So therefore we can obtain a relation, that is M1A1 is equal to M2A2, right? And which implies M1 by M2 is equal to A2 by A1. This is equation number, so let me take it, this is equation number 1, and let me take it, this is equation number 2. Solving 1 and 2, the masses of stars can be determined, right? That's how masses of stars can be determined. So hope you have understood this. Now let's move on to next question. So next question is 3B. Discuss any one coordinate system used in astronomy. So let us discuss about geographical coordinate system. This is 3B answer, right? Answer to question number 3B. So I'm not gonna explain this, just write the answer. As you can see here, they pause the video and note it. So here is the next page, and figure 2.5 means this figure. This is the 2.5 figure, so you can name it as you want. Okay, so now you see, this is the first page, this is the second, okay, and this is the third, and just wait. Okay, 3 pages are there. First take the screenshot of this, then this one, and at the end this one. So this is the geographical coordinates, okay, that used in astronomy. There are different coordinate system, but here we are asked to discuss about only one. Okay, so now let's move on to the next question. So next question is here we need to define sidereal time and explain why sidereal day is shorter than the solar day, What do you mean by solar time? So let us discuss about the sidereal time. This is 3C, answer to question number 3C. Now you see, on the here you see the basic unit of time, the day, is defined as the time required for the earth to rotate once its axis. If this rotation is considered with respect to the sun, then the time for one rotation is relative to sun is solar day, one solar day. And on the other hand, rotation period of earth relative to a distant star, if you consider distant star, is called sidereal day. The sidereal day is different from solar day. Okay, this difference arises due to the earth's revolution around the sun, right? So now, but what you gonna write when definition of this sidereal time is asked? So let me write the definition. Okay, this point is A, this is B, this is. Now let me explain why this sidereal day is shorter than a solar day. Now you see, this is a place F here on the earth's surface. Okay, now this solid arrow is pointing towards the earth, and there is another star which is very far away from the sun, just behind it. Let me consider that way, and both are overhead. That's why at this position it is noon, and here it is midnight, right? So now you see, this earth has two motions. One is revolving around the sun, and one is rotation of its own body about its own axis. That is one. So now you see, this is very far away from the sun, and that's why when it will go to this position B, then what happens? Now you see, this is the star very far away, and this is the sun, and this is the earth, suppose. Now these two are overhead. This is the sun and this is the star. Okay, so when this will be at this position, right? Now let me consider this solid arrow is pointing towards the star. So after rotation, okay, after rotation about its own axis, okay, after rotation of the earth about its own axis, okay. Now you see, when the earth was at this position, this line was pointing towards the sun and the star both, right? So when it comes to this position and it is rotating as well, okay, then when this solid arrow will be pointing towards the star, which is far away from the sun, that will not be pointing towards the sun. Okay, now they are not overheaded. So when this solid line will point towards the sun after some time, and after this revolution, okay, after this rotation at this position, after time t, suppose a certain time t, this arrowhead, this solid arrow pointing towards the star, suppose. That means this is the earth, this is rotating this way, and solid arrow is also rotating this way, right? And this is also revolving about the sun like this. So now you see, just wait, let me explain it properly. So now you see, this earth is going to this position, this is rotating like this, right, and going forward, then again one like this way, this arrow will be rotating, right? So now you see, when this arrow will be pointing towards again pointing towards the star, which is far away from the sun, then we're going to consider that time interval is one sidereal day. But it needs more time to be pointing towards the sun, right? Now these two are not on the same line, okay? So that's why this now you see, to complete one solar day, this earth has to reach this point where this solid line will be pointing towards this sun, okay? So that's why you can see that the solar day, one solar day is longer compared to the sidereal day. So one sidereal day is shorter than the solar day. Hope you have understood this. So this is the explanation here, okay? And you have to write this one as well. So let me write here. This is sidereal time. What do you mean by sidereal time? Then you have to write this definition. Okay, now let's move on to next question. Question is, write about the equation of time. Here I'm not going to explain this, okay? Just I'm going to give you the answer. This is the answer to question number 3D. So here you have to draw this diagram. Here I have written what are the things that should be considered, and this is the first phase and this is the second. Okay, you can write the equations number as you want. You can start from here 1, 2 and so on. Okay, then you have to change here also according to your consideration, okay? And this is the equation of time, right? And meaning of the symbols are mentioned here. What are the symbols used? Okay, so and this is the diagram here. Draw this diagram as well. So in the next video we're gonna solve the remaining questions. So thank you for watching. See you in the next video. So do subscribe the channel if you are new to my channel. Also share with your friends. Thank you.